The Philippines became a member state of the International Atomic Energy Agency, or IAEA, in 1958. The Philippines has been a solid and productive partner in the realization of the IAEA's Atoms for Peace program. At the center of this fruitful cooperation for more than half a century is the Philippine Nuclear Research Institute, or PNRI, formerly the Philippine Atomic Energy Commission. PNRI is a research and development institute and the national nuclear regulatory body under the Department of Science and Technology. PNRI spearheads the development and applications of nuclear science and technology in agriculture, health, industry, and environment to address the country's needs. PNRI scientists are developing precision farming methods using radioisotopes and stable isotope tracers such as nitrogen-15. Precision farming methods are undertaken to determine the right amount and proper timing of fertilizer application at different growth stages of staple food crops such as rice and corn. Soil moisture neutron probe and other related techniques are being used to optimize irrigation scheduling, while carbon-13 and oxygen-18 isotopes are used to evaluate and assess the effectiveness of different irrigation technologies. Results show that better practices can increase fertilizer utilization up to 70%. Appropriate irrigation scheduling can improve crop water use efficiency and minimize losses by around 25%. These will serve as bases for updating the decades-old recommended levels of fertilizer and water inputs in agricultural production. The preliminary findings are being shared to the project's beneficiaries and stakeholders, local government units in the nearby provinces and municipalities, and other farmer cooperators. PNRI scientists have developed plant growth promoters, or PGPs, from radiation-processed natural polymers such as carrageenan and chitosan. Results of initial pot experiments on mung bean and peanut showed that the PGPs from irradiated carrageenan and chitosan increased the crop yield by 200 to 300%. Field experiments are currently being conducted at Cagayan Valley Research Center in Isabela Province with promising results. Field testing on rice sprayed with PGPs resulted in plants showing no signs of rice tungro disease infection. The field test was conducted at the University of the Philippines, Los Baños in Laguna Province. Through radiation technology and mutation breeding, PNRI conducts studies on improving the quality of adlai. Adlai is a tall grain-bearing tropical plant from the same family as rice and corn, which grows abundantly in the country and may also serve as an alternative staple food. Results of PNRI studies show that the plant height of irradiated adlai decreased by up to 1 meter, making them more resistant to lodging caused by strong winds and typhoons. Gamma irradiation can also be used to control the population of various pests that damage agricultural crops and serve as carriers of viruses and diseases. These problems are even more prevalent in tropical countries such as the Philippines. PNRI scientists previously used the sterile insect technique, or SIT, against fruit flies that infest export fruits like mangoes. The Institute later expanded its applications to help mitigate the perennial dengue problem in the Philippines. A stock colony of Aedes aegypti was established at the PNRI laboratory as a source of test insects for various experimental tests, leading to the development of SIT against the dengue mosquito vector. Around 39 nuclear medicine facilities in the Philippines are licensed by PNRI. These facilities use technetium-99m and other radioisotopes for diagnosis of the state of health of various human organs and treatment of certain diseases. Through its newly established technetium-99m generator facility, PNRI paves the way for cheaper and more available supplies of radiopharmaceuticals in the country. This facility was established with IAEA technical assistance. The local production of technetium-99m will save the medical industry up to around 20% of the average cost for imported technetium radiopharmaceuticals. PNRI has been recently licensed by the Food and Drug Administration to operate the facility. Proposals are also being considered to make technetium-99m available at subsidized costs to government hospitals and charity patients. Medical cyclotron facilities enable the local production of medical isotopes which serve as tracers in positron emission tomography or PET imaging. PET imaging is used to diagnose various oncological, neurological, and cardiovascular diseases. The first medical cyclotron in the country was set up in 2001 at St. Luke's Medical Center as an in-house facility. With technical assistance from the IAEA, PNRI coordinated a task force composed of private and government sectors to set up the second medical cyclotron facility in the Philippines. The cyclotron was recently established by the private sector in cooperation with the National Kidney and Transplant Institute. The centralized medical cyclotron facility will allow PET-CT imaging to be more accessible to several hospitals and can even halve the cost of these procedures. This facility will further modernize nuclear medicine in the country. Aside from surgery and chemotherapy, radiotherapy is another method for treating cancer through the application of ionizing radiation. PNRI monitors about 36 radiotherapy hospitals and medical centers in the Philippines to maintain the required level of safety and security according to IAEA standards. The nuclear medicine and radiotherapy professionals, through their respective professional societies, are participating in the IAEA Quantum and Quattro projects to enhance quality of procedures and patient care and ultimately nuclear safety. Quantum stands for Quality Assurance in Nuclear Medicine, while Quattro is Quality Assurance Team for Radiation Oncology. Harmful algal blooms, also known as red tide, has always caused damage to the health and business of fishing communities and consumers alike, a problem that makes an archipelago such as the Philippines especially vulnerable. In 2005 and in 2010, IAEA designated the PNRI as a collaborating center in harmful algal bloom studies. The Institute engaged in research and development on receptor binding assay, or RBA, which has been approved by the Association of Official Analytical Chemists International in 2011 as the analytical tool for paralytic shellfish poisoning. The PNRI is transferring the RBA technology to the Bureau of Fisheries and Aquatic Resources as an alternative to mouse bioassay. In cooperation with the University of the Philippines Marine Science Institute, PNRI currently undertakes various researches on harmful algal blooms, shares its expertise, and accepts trainees from other IAEA member states. Stable isotope ratio mass spectrometry is used for analyzing the geographic and botanical origin of samples, as well as the methods and mechanisms used for their production. In 2008, PNRI established its own isotope ratio mass spectrometer, or IRMS laboratory. The IRMS laboratory facilitates many of PNRI's environmental research involving water resources and drainage basin studies, and for the precision farming project to measure fertilizer and water uptake by plants. The IRMS facility is also used for the analysis of food and other samples to determine their provenance or origin. PNRI's IRMS facility made isotope analytical services cheaper and more accessible to local researchers. The PNRI and the Bureau of Soils and Water Management, or BSWM, used the stable isotope technique to trace the sources of pollutants entering the Manila Bay from the Pampanga River Basin. The mixing models reveal that domestic and cropland sources contributed dominantly in the pollution along the Pampanga River Basin leading to Manila Bay. The Department of Environment and Natural Resources is again contracting PNRI and BSWM to replicate the study with the 3 other river basins discharging into the bay to get a complete picture of the pollution loading in the Manila Bay. The PNRI has been using radiation from the Cobalt-60 facility since the late 1980s with successful results. The Cobalt-60 irradiation facility has been used in the sterilization of medical devices, packaging materials and pharmaceuticals, decontamination of cosmetic raw materials, spices, dehydrated vegetables and herbal products, extension of shelf life of food, and quarantine treatment of fruits and vegetables. The present multi-purpose irradiation facility is now being used on a semi-commercial scale. The new 2.5 MeV electron beam facility at PNRI is capable of delivering higher dose rates, thus widening the applications of radiation processing, such as radiation cross-linking and polymer grafting. The establishment of the electron beam facility in the Philippines received financial support from the IAEA and the Japanese and U.S. governments under the Peaceful Utilization Initiative. The PNRI received counterpart funds from the Department of Science and Technology, Grants in Aid, and the national government for the facility. To help enhance the export competitiveness of Philippine super mangoes, PNRI has developed a quarantine treatment using gamma irradiation against the mango pulp weevil. Based on PNRI's research studies, a minimum radiation dose of 165 gray is enough to make the adult mango weevil sterile, providing sufficient quarantine security for the Philippine mangoes. The quarantine treatment was already published as a final rule in the United States Federal Register in October 2014. The U.S. Department of Agriculture has also recently expanded the weevil-free areas in the country beyond Guimaras Island, finally allowing more Philippine mango exports to enter the United States. In collaboration with the Bureau of Plant Industry, PNRI will also play a major role in implementing the quarantine treatment through the upgrading of its semi-commercial irradiation facility. As the national nuclear regulatory body, the PNRI formulates rules and regulations on the safety and security of atomic energy facilities and radioactive materials. The PNRI grants licenses to industrial, commercial, medical, educational, and training sectors for authorization to use, possess, produce, store, sell, transport, or import radioactive materials. The Philippines continues to participate in the international effort to address nuclear security and prevent nuclear terrorism under the Global Threat Reduction Initiative and Megaports Initiative. In support of the Megaports Initiative, radiation portal monitor systems were installed at the ports of Manila and Cebu to detect, deter, and prevent illicit trafficking of nuclear and other radioactive materials. The monitoring systems were donated through a memorandum of intent between the U.S. and the Philippine governments under the Megaports Initiative of the U.S. Department of Energy. To ensure sustainability, the European Union is donating a radiation portal monitor and other equipment for training of port operators and Bureau of Customs personnel. PNRI operates the only centralized radioactive waste management facility for low-level radioactive wastes in the country. This provides for the treatment and temporary storage of immobilized, disused radioactive sources and other waste packages for interim storage. A project on conditioning spent high-activity radioactive sources was conducted in cooperation with the South African Nuclear Energy Corporation and the IAEA. This project was undertaken to ensure safe and secure management of these sources in a long-term storage container, reducing radiation levels at the surface and eliminating the risk of overexposure and possible covert action. PNRI is evaluating a site for the final disposal of low and intermediate level wastes. The site evaluation is being undertaken with other government agencies. The Institute envisions to co-locate a near-surface radioactive waste facility with the IAEA recommended BOSS facility for disused sources. The PNRI Nuclear Training Center conducts training courses, seminars, and workshops for various groups and sectors on capability building in the field of nuclear science and technology. The training courses tackle on the applications of nuclear S&T and on radiation and nuclear safety. Laboratories and facilities of the different research units in PNRI are made available to the trainees, in addition to arrangements made with other private companies, government agencies, universities, and hospitals. PNRI also conducts training courses on non-destructive testing in cooperation with the Philippine Society for Non-Destructive Testing. The PNRI Nuclear Training Center has been accredited by Lufthansa Technique Philippines as an NDT training service provider per European Standard EN 4179. The IAEA has selected the Philippines as one of the pilot countries in launching an outreach program on nuclear science and technology for secondary schools. This project is being undertaken through the collaboration of the PNRI and the Quezon City Division of City Schools of the Department of Education. The IAEA develops a compendium of resources and activities for use by high school teachers and students. The compendium will be tailored to the flow of DepEd's K-12 basic education curriculum, such that it may touch on the basics of nuclear science and its applications. Like the atom that is filled with great energy and potential, the future prospects of nuclear science and technology in the Philippines remain bright as day as the country continues to cooperate with the IAEA through its contributions in agriculture, industry, health and medicine, environmental protection, nuclear safety, and safeguards and security. It is PNRI's mandate to continue serving as the beacon for the country as it moves forward with nuclear science and technology.